Math 1314, section IC1, spring 2022, Tyler Junior College, section 1.7, absolute value inequalities, video 3, greater than inequalities. In the first two videos, we talked about less than inequalities, which have a very specific approach to solving them. In this video, we'll be talking about greater than inequalities, which also have a very specific approach to solving them. They're a little bit similar, but they also are a little bit different. So it's going to be important to keep them sorted out. Consider an inequality of the following form. Absolute value of expression is greater than a number. And there's that asterisk again, and you probably remember what that asterisk meant before. But in case you didn't, I'll remind you, this asterisk means that this number is positive. Greater than 0, if you will, but it means the same thing. Positive means greater than 0. And we'll recall we'll look at the case where it's 0 and where it's negative in the next video. Recall that absolute value measures distance from 0. Not sure what I spelled there. So when you see something like expression is greater than a number right here, then you can think of it in terms of a number line saying that the distance from the expression to 0 is greater than this number. So let's whip out a number line, drop 0 on it in the middle. Let's put the number here. And what does it mean for the expression to be more than that from 0? In other words, the distance from the expression to 0 is greater than that number. That means that we have to travel further from 0 than this number, which means our expression has to be over here for its absolute value to be greater than that number. But that's assuming that we measure the distance going to the right. If we measure the distance going to the left, then we have the negative of that number over here. And if the expression is further away from 0 than that, then it has to live over here. Now, compare that to what we saw for less than, and I have that PDF open here. When we had that for less than, the expression was trapped between the number and its negative. But when it's greater than, then we have to go beyond those numbers, and therefore our expression can actually live in two locations. It can live to the right of the positive number or to the left of the negative number. Now, what does it mean for the expression to live to the right of the positive number? That means that the expression would have to be greater than that number. Let's bump that font size up. Because when you're to the right of something on a number line, that means you are greater than that. So on the right side, we have expression greater than that number. But what do we have on the left side? On the left side, the expression is to the left of the negative of that number. And when you're to the left of something, you are less than that. So we have expression less than the negative of the number. Now, it can't be in both places at once. Unlike here, where you could simultaneously be to the right of negative number and to the left of negative number. In this case, you can't be in both places at once. You're either to the left of the negative or to the right of the positive. Well, notice that these two expressions down here do not have an absolute value, and therefore both are going to be solvable. And we can't have both of these at the same time, so we have to have either one or the other. So right in the middle of these, I'm going to put a giant or, and this is going to kind of demonstrate how we're going to set these up. We're going to say, we're going to turn this into an or compound inequality, and we've talked about solving those before. So let's make this a little bit more rigorous in terms of when you see this, then we do that. The inequality, absolute value of an expression is greater than a number, is equivalent to the following. Expression is greater than the number, or expression is less than the negative of the number. And in this, again, this correlates to the visual that if your absolute value is bigger than something, then either you have to go far enough to the right, which is the first part, this part right here, or far enough to the left, which is this part right here. So we can rewrite an absolute value greater than problem as an or compound inequality. And by the way, just as a reminder, all of these are assuming that the number is positive. Assuming the number is positive. If it's 0 or negative, it'll be special cases that we'll look at separately. All right, so let's take a look at an example, solve it, put it on a number line, and then come up with the interval notation for the solution. For example, solve the absolute value of 3x minus 1 is greater than or equal to 14. It's worth pointing out that the or equal to does not change anything that happened here. The only difference is if it said or equal to here, then it would say here and here as well. Of course, that will have an impact. When we draw the number line, we'd have to use brackets instead of parentheses. And when we write the interval, we would also have to use brackets instead of parentheses. All right, so how do we do this? Well, just a reminder for the visual, what we're saying is that the expression 3x minus 1 is at least 14 spaces away from 0, which means 3x plus 1 has to live over here to the right of 14, or it has to live to the left of negative 14. So we can just write an inequality for each of those visual relationships. For the one on the right, that means 3x plus 1 is greater than or equal to 14, which is kind of funny that I'm writing it first, which puts it on the left. But I like writing this one first. Excuse me, those should be minus ones. What am I doing? What am I doing? Now, if you're thinking, but absolute value makes negatives positives. Yeah, but we don't know if this expression is positive or negative yet. So we can't just go in and turn the 1 positive because the 1's being subtracted from something before we do the absolute value. But as I was saying, I'm writing this one first, even though it shows up on the right side over here, because really, if you think about it, that first inequality is just this one without the absolute value. In other words, you just drop the absolute value and solve that. But the other one is what you would get if 3x minus 1 were on the left of negative 14. So it's almost like to get the other one, you just reverse the inequality and then change it to a negative. There's a lot of gimmicky ways to remember how to get from here to here. The visual, the literal, where you just drop the absolute value for one and then switch and negate for the other. I'm sure there's some other gimmicks that you can come up with, but it's kind of obvious that it's critical to be able to get from the problem to the bottom line, because the bottom line right here contains no absolute values. And so that's what we can solve. Speaking of which, let's finish solving. We're going to add 1 to both sides of both of them to get rid of the minus ones. That would leave 3x on the left of the first inequality, greater than or equal to 15 on the right side of the first inequality, or the plus and minus 1 cancel on the second inequality, leaving 3x on its left, less than or equal to, and on the right side, negative 14 plus 1 is negative 13. And then we're almost done. We just have to divide everything by 3. Some of them will cooperate, such as the first inequality. We get x is greater than or equal to 5. Or some of them won't be as cooperative. On the second one, we get x is less than or equal to negative 13 thirds, because 13 thirds won't reduce. All right, so that wasn't too bad, but we're not out of the woods yet, because now that we've solved this inequality in the literal sense that we've got the x by itself, well, granted it's in 2 separate inequalities, but that's okay. Now we have to put this on a number line and see what it looks like as an interval, which in this case will actually be 2 intervals. You may recall that when you graph the solution to a compound or inequality, it is the union of the 2 solution sets. Loosely speaking, that just means that we draw both of these on the same number line. And if they overlap, then we merge them into one interval. These won't overlap, however. We do need to locate 5 and negative 13 halves. It doesn't matter where we put them, as long as they're correct relative to each other, meaning that the lesser number should be written on the left somewhere and the greater number should be written on the right. Now, we just need to shade in the correct portions of the number line. For x is greater than or equal to 5, greater than means to the right of 5, so we would shade to the right of 5, but the or equal to means that we would put a bracket on the 5. And for the other one, x is less than or equal to negative 13 halves, Less than means to the left, so we would shade to the left. And then the or equal to means we can put a bracket on there. The number line would be shaded from negative infinity to negative 13 halves with a bracket on negative 13 halves. And then again from 5 to infinity with a bracket on the 5. All right. So what's the interval notation? Well, the interval notation is just a description of what's shaded in, and I literally just said it. The left portion of the interval begins at negative infinity, comma, ends at negative 13 halves. But because the negative 13 halves is included, that has a bracket, the right part of the number line has a bracket opening with the 5, comma, and then goes all the way to infinity. And remember, when your number line has disconnected, disjoint parts, if you will, you write an interval for each and then a union in between. So the solution is open parentheses, negative infinity, comma, negative 13 halves, close bracket, union, open bracket, 5, comma, infinity, close parentheses. Before we wrap up this video, I want to pose 2 questions that we're going to answer in the next video, because think about how we did this problem. We had something that said absolute value of an expression is greater than a number. We rewrote it as an or compound inequality, and then we solved it, and we were assuming that number was positive. So the 2 questions we need to answer are as follows. Number 1, what if the inequality is not of the form absolute value of an expression is greater, I can't type this morning, is greater than a number? Well, we kind of already know the answer to that because we saw it previously where we would just manipulate things until it got to that form. And of course, the other question is, what if that number is 0 and what if it's negative? Well, we'll figure that out in the next video.